Hey guys, welcome to Technical Ecology. This is Kalpran, and we are back to the episode 4 of our R series. And like we discussed in the earlier video, we are going to talk about matrix and arrays. So today is the second part of the matrix series, so there'll be a total of 3 videos, and today is the second video. So without further ado, let's get into it. It's fairly going to be a short video. It's not going to be a long one. So let's get started. Right, let's head into the screen and open our studio. All right, I think I should have my file open. Yep. Ignore update. Right. So what this video is basically going to be about is just matrix and its operations. Again, I can't emphasize on this enough, but matrix is really important if you want to understand the regression part of it in the later videos, or let's say how to extract data from tables, which are very similar to matrix, but the calculations of matrix don't play in. Moreover, matrix are really helpful in creating confusion matrix, which might sound confusing, but they are a really integral part of k-fold validation, which is again a part of machine learning experience that which we'll talk about later. Let's not go deep into it. Okay, so like I said, you can either use matrix for storing or operating on results, as we did until now, or we can use matrix for its mathematical properties. By mathematical properties, what I mean is that you can use it in regression models to find coefficients, or you can use matrix to multiply two tables, or even subtract or add elements to a table, to every observation of a table. It's very similar, or every index of a matrix, right? The mathematical behavior of matrix is not always the same as the more generic data. Like if you use a normal table, and if you just want to add one data point to a certain observation, it is possible. But in matrix, it works in a way more complex manner, which we will talk about in this video. Right, so let's get to basic math. So I remember learning about matrix in my 8th standard or 7th standard, probably. No, I think it was 8th standard, and I've forgotten about it completely until I was like again reading through all the matrix operation before making this video, right? So let's talk about matrix transpose. So what we mean by matrix transpose is basically you change, like if let's say you have a 3 by 3 matrix, so you have or let's say 2 by 1 matrix, you have 2 rows and 1 column. Now if what a transpose matrix of that 2 by 1 matrix would be a 1 by 2 matrix. So basically what you do is you change the columns into rows, or the rows into columns. The interchange of that is called a transpose matrix. So let's see an example. So I've created a matrix here called A using rbind. So we basically have a 2 into 3 matrix here, because we have 3 observations and 2 rows. So if I run this and then I run A, you can see it's a 2 by 3 matrix. Now to find the transpose of a matrix, there's a very simple function called T, and you just enclose it within the matrix within first parentheses, and then when you run that, you get the transpose matrix. So you can see that the number of rows now have that's sorry, that's 2 here, has become 2 columns now. Like it has interchanged. Now a transpose matrix of a transpose matrix is basically the original matrix that you had. So if I just run the transpose matrix on the matrix A and then run a transpose of that matrix, what will basically end up is with the first matrix itself. So let's just try that, and you can see here it's the same matrix. The next thing I want to come to is identity matrix. So identity matrix is basically matrix where you just have 1 and 0 as the elements of the matrix. So there are no other values called 2, 3, nothing. There's just 1 and 0. and the ones in the diagonal, like we spoke about in the earlier video, we used the diag function to extract the diagonal of matrix. So the ones that are in a diagonal, so it's like 1 zeros. If it's a 3 by 3 matrix, it'll be 1 0 0 0 1 0 and 0 0 1. So let's just run this and I'll show you. So using the diag function again, if we specify the number of rows that we need, it will create a matrix of that n number of rows. Let's say here we have given 3, so it will create a 3 by 3 matrix, 3 by 3 identity matrix. However, the same function is used to extract the diagonals as well, but in that case you just need to put in the matrix here. Like if we want to extract the diagonals of, let's say, matrix A, then we just put in A in this first parentheses, and it will extract the diagonals. Now if we give x equals to 3, it will create a 3 by 3 identity matrix. So let's just see that. You can see it's a 3 by 3 matrix, and the identity, it's an identity matrix because it has 1 1 and 1 in the diagonals, and it's like 1 0 0, and the other elements are 0 basically. Now what I mean here by scalar multiple of matrix is that if you multiply a single element with a matrix, it will multiply that single element to all the elements of the matrix. So it will multiply to all the indexes. So what I mean here is, let's say we create a matrix again, the similar matrix. So we'll just run a for now here. Yep, what happened? Nope, there we go. So if I run this, you can see this is our matrix here. Now if we specify another object called A, which stores the value of 2, and if you multiply A, the small a, by capital A, which is the vector here with the object here with the A matrix, what we will get basically is that 2 here will multiply to each and every index of it. So it will multiply 2 into 4, 2 into 6, 2 into 7, 5 into 2, 3 into 2, 1 into 2, and then it will give you the resulting matrix. So let's just run it. So you can see here it's like 2 into 4 is 8, 2 into 6 is 12, 2 into 7 is 14, 2 into 5 is 10, and so on. So you basically get the point. So that's how scalar multiple of matrix works. But you can also subtract and add matrix matrices. So how you do that is, like, let's create another matrix called B, which will basically be let's just run B. Yeah, so this is B here and this is A here. So when we subtract or add a matrix, the indexes are always, it's not like it's subtracted or added with all the indexes, but what happens is that each index of the first matrix is subtracted from the other matrix. So what I mean is that, I'll just show A here again and then B here again. So what it will basically do is it will subtract 2 from 4, 5 from 6, 2 from 7, 6 from 5, and so on. So you can see that the indexes are same. So one first row first column will subtract with first row first column, first row second column will subtract with first row second column, and so on. So if we just run this, you can see here that it's 4 minus 2 is 2, 6 minus 5 is 1, 5 minus 6 is minus 1, and so on. So that was basically about addition and subtraction. It's fairly simple here. Now when we talk about multiplication, it's a bit different. So to multiply a matrix, you need to have one criteria first, that the number of columns of the first matrix needs to be similar to the number of rows in the second matrix. So let's say if it's a 2 by 1 matrix and you want to multiply it with a 1 by 2 matrix, so that won't be possible because a 2 by 1 matrix number of that would be possible because the number of 2 by 1 matrix which has one column and 1 by 2 matrix which has one row is similar. So so number of columns is equal to number of rows, which will be functional, I would say, to multiply. So the resulting matrix that you'll get if you multiply 2 by 1 matrix and into 1 by 2 matrix is that you will get a 2 by 2 matrix. So you can see here that I've written row into column. So what I mean by that is that the row of the first matrix into the column of the second matrix will be the resulting matrix, like the resulting matrix after multiplication. It sounds quite complex right now, but if we just do it once, then we'll come to know. Also, I want to put into perspective that multiplication is not commutative. So C into D is not equal to D into C. So if C and D are two matrix, so C multiplied by D is not equal to D multiplied by C, which is in case of normal integers. Like 2 multiplied by 5 is equals to 5 multiplied by 2, right? So it's like 10 and 10. But here, in case of matrix, it's kind of different, right? So let's get in here. We can see here that I have assigned another matrix to the object B. So if we run it here, and then let's see, yep, the matrix is there. So now I want to know the dimensions of A. Like we had talked about the dim function earlier. It will give you the number of rows and the number of columns. So dimension of A and dimension of B, you can say, is 2 into 3 and 3 into 2. So first of all, the number of columns is equal to the number of rows. So this can be multiplied. If these two were different, then it wouldn't be possible to multiply. And the resulting matrix will be a 2 by 2 matrix. The first row, I mean the number of rows of the first column into the number of rows of the first matrix into the number of columns of the second matrix. So let's try that. Okay, another thing, you can't use the conventional multiplication, the asterisk symbol, to multiply two matrix. What you need to do is you need to put modulus, asterisk and modulus here to basically multiply two matrix. Okay, let's see this now. You can see here that matrix multiplication is not like index by index, because if it was index by index, then A and B. If it was an index by index, it should have been 4 into 2 is 8, but we have 52, and the number of rows and the number of columns, they don't match either. Okay, so how the multiplication happens is that, let's just show it here, it will be much more easier. So the first row is multiplied with the first column. So there's a first row is multiplied with the first column of the second matrix, and then the multiplication done is in an index manner, and then the first row again is multiplied with the second column of the second matrix. So what I mean is the first row here is 4, 6, and 7 is multiplied with 4 is multiplied with 2, 6 is multiplied with 5, and 7 is multiplied with 2. So 4 into 2, we will get 4 into 2 is 8, and then 6 into 5 is 30, and 7 into 2 is 14. So let's see, 14 plus 30 plus 8 is 52. So the first row, first column of the multiplication of the matrix is 52. Similarly, for the second index of the multiplied matrix, what we will do is we will multiply the first row of the first matrix with the second row of the second matrix. The second column of the second matrix. So 4 into 6 is 24 plus 6 into 1 is 6 plus 7 into 4 is 28, which is 58. So you can see, and then the process again repeated. So this second row is multiplied with the first column, and then the second row here is again multiplied with the second column. So that's how basic multiplication is done in case of matrix. Now what I mean by not commutative, c into d is not equal to d into c, you can see an example here. So a into b is this matrix, and if you run b into a, you can see it's a different matrix altogether. So that's because this was a was a 2 by 3 matrix and b was a 3 by 2 matrix. So when we reversed it, so the number of the new matrix basically will have 3 rows and 3 columns. So it's a 3 by 3 matrix, whereas in the first case it was a 2 by 2 matrix. Right. So that was basically about the basic operations, arithmetic operations of matrix. Now the final thing I want to talk about here is how to find the inverse of a matrix. So an inverse of a matrix is very simple to find. It is denoted by I, is by using the solve function. So, and one more thing to remember is that in an inverse matrix, it cannot be a rectangular matrix. It needs to be a square matrix. That's like a 3 by 3, 2 by 2, 1 by 1, or let's say a 4 by 4 matrix. All the square matrices that can be inversed. What I mean by inverse is basically 1 by whatever the element. So an inverse matrix is basically when you multiply a matrix called A into its inverse matrix will give you an identity matrix. So A multiplied by 1 by A is equals to I, which is an identity matrix. Identity matrix is again 1 0 0 0 1 0 0 0 1. Basically the number of ones are in the diagonal and the rest of the elements are 0. So an easier way to do that in R is basically use the solve A function. Okay, so let's try solve of A to find the inverse matrix of A. Just run it. I can see it throws up an error because it's not a square matrix. So let's first of all create a square matrix. There you go. This is a square matrix. You can see there are 4 elements and number of rows is 2, number of columns is, so it's a 2 by 2 matrix. Now let's find when I told that multiplication of an inverse matrix with its original matrix is an identity matrix. Let's see if it's true or not. So to get that, what I do is A multiplied modulus into solve of A. You can see here it's an identity matrix. So with that being said, we wrap up this R tutorial. It was a very short tutorial because I have been doing a lot of other stuff these days. But regardless, in the next episode we are going to talk about the more complexities of matrix and arrays and how to work with it. And after that, I've seen that I've been talking about the simple stuff a lot. So what I have taught up until now, I'll try and make a more complex video, let's say a regression model, or I'll talk about GLMs or different kinds of regression models and predicting data using machine learning, using GLMs, and again validating those stuff. So yeah, exciting videos are coming up. With that being said, I hope you understood how matrix works, because matrix is very useful later on, especially when we delve into machine learning and validating models that we create. So with that being said, we have come to the end of the video, and I hope to see you back in the next one. Have a nice day and see you soon.